Alright, Unit 2, Lesson 6. We are trucking right along. And today, who knows if this is today or the same day as the last one. Never mind me, I'm just talking to myself here a little bit. But in this lesson, we are going to solve absolute value inequalities, both with a less than and a greater than symbol. So let's get right to it. You can see I've got you a little box of information here to start with. So let me highlight a few things. There's some important details here. So first of all, we've got an absolute value. We know we've got an absolute value. It's less than a. Now this is an important part right here. If a is a positive number, this is all based on the fact that a is a positive number. If that is the case, then we have this inequality that we can write right here. Negative a is less than x, which x in this case represents whatever is inside the absolute value bars, is less than a. So basically we take that absolute value inequality and we turn it into a compound inequality that we can then solve and get our answers from. Now let's think about why a has to be positive. Because, for instance, let's say this. If the absolute value of, let me just make something up real quick, 3x is less than negative 2, for instance. Think about what absolute value means. Absolute value means distance from 0, and it can never be negative. Absolute value is always positive. So there's no value of x that you can plug in here and get a number that's going to be less than negative 2. It's just not possible, because whatever you plug in, you're going to get an absolute value, and that absolute value is going to be positive. So that's why this number that's over here has to be positive for us to even think about working the problem. If that's negative, then we know right away we have no solution. And we'll look at an example like that here in just a minute. But let me get rid of that now and reuse this space. So let's look at a fairly basic example. We're going to solve this for y. We've got the absolute value of y minus 3 is less than 7. Okay, well let's just apply this property that I just said right above here. So 7 is my a in this case. So that means I can rewrite this as negative 7 is less than y minus 3 is less than 7. Okay, I just took the y minus 3 because it's inside the absolute value bars, and that goes in the middle of my compounding inequality. And all I have to do is put a negative version of the number on the right on the left side. Now we're just going to solve this like we already know how to. We want to solve for y, so all we have to do here is add 3 to both sides. How convenient. And I get, well, negative 7 plus 3 is negative 4 is less than y, is less than 10. So, in other words, y has to be between negative 4 and positive 10 in order for this to be a true statement. And you can check that out. You can pick some values in between there and see that that's true. But just to show you why it's not true, let's say y is negative 5. If you plug negative 5 back in up here, negative 5 minus 3, well then you have the absolute value of negative 8, which is equal to 8, and that is not less than 7. Okay, so you can see why that would be not true. And you can see the same thing would happen if y was bigger than 10. So our solution set is anything in here. And just as a refresher here, remember this can also be written in interval notation, and the interval would be negative 4, comma, 10. And remember we'd have parentheses on both ends because it's not or equal to. Right? Y is less than 10 and y is greater than negative 4. So we have parentheses instead of brackets. Alright, that was pretty straightforward. Let's do one that's slightly more complicated. The absolute value of 5x plus 1 is less than or equal to 10. Let me put a little line here to separate these two problems. Okay, first thing first. We've worked absolute value problems before. You know you need to isolate the absolute value, and that is still the case. So the first thing I need to do is get rid of this plus 1 that's hanging out right here by itself. So let's subtract it. Remember, you can work an inequality just like an equation. We can move terms from one side to the other just like we do in an equation. The only difference is if we divide by a negative, we have to flip the direction of the inequality sign. So now this gives me the absolute value of 5x plus 1 is less than or equal to 9. And now I am ready to set up my compound inequality now that I've got the absolute value all by itself. So I'm going to come over here to the side and do that. So that gives me negative 9. I'm coming right over here to do this. Negative 9 is less than or equal to 5x plus 1 is less than or equal to 9. Alright, now let's look at how are we going to solve for x. In the middle of this inequality, I've got 5x plus 1, so I am going to start by subtracting 1 everywhere. Since this is a compound inequality, I actually have to do that 3 times. Right? That cancels out my 1's here. So now I've got negative 9 minus 1, that's negative 10, is less than or equal to 5x is less than or equal to 8. 9 minus 1 gave me 8. And one last step, divide by 5 to get x by itself. Divide by 5, divide by 5. And that gives me, slow down a little bit, negative 2 is less than or equal to x is less than or equal to 8/5. You really can't do anything with that. So let's just leave it as a fraction, 8/5. Now, I will point out, notice, even though this answer over here is negative 2, even though this right here is negative 2, I didn't flip the direction of the sign. The inequality sign stayed the same because the number I divided by was 5. Right? I divided by 5. It doesn't matter that I got a negative. It matters that the number I divided by was not negative. You know, that's what would determine changing the direction of the sign. So here's my answer, and let's write that in interval notation again, just to get comfortable with that, because you're going to see it both ways. This time I do have brackets, right, because of the or equal to. Well, I'll switch back to my pen. Let me go back for a second. Because of that right there and that right there. I've got or equal to under there, less than or equal to symbols. That means I use brackets. So I have bracket negative 2 comma 8/5 bracket to close it. And there is my interval in interval notation. Just so you see this, because you'll also see it on a number line. If you were asked to graph this, what would it look like? Well, really you just need 2 points. Here we'll call this one negative 2. We'll call this 8/5. And complete my 8. Oh, sad. There we go. And what would a graph look like? Well, we would have brackets at these 2 points, closing them off. And then everything in between there would be highlighted. So you'd have, this part would be shaded in. And you'll have to ignore that my, let me see if I can, whoop, I got the wrong thing. Oh well. Let me fix that real quick. You get the idea. So we have a bracket at negative 2, a bracket at 8/5, and everything in between is shaded. Okay. Well, looky there, I used up all my space I allotted myself. I actually want to, let's see if I can move this. No, I don't want to move that. I just want to move, no, I don't. Oh, my hand. My panning hand. Oh, let's see, this will work better. Yes, that's what I want. You get to be in on the process while I attempt to figure out the technology. Isn't that fun? Yeah, it's a little bonus of the course. Okay. I kind of mentioned this a second ago, but if I wrote this problem, I just don't want you to forget about it. So let me just remind you. Let me write one that looks kind of complicated. 2x minus 1/10. The absolute value of 2x minus 1/10 is less than negative 13. Let's say I gave you this problem right here. Now, what you should notice right off the bat is this number is negative. You do not even need to work this problem. There's no way you can get anything inside of the absolute value that's going to be less than negative 13, because when you take the absolute value, it's positive. So the answer here is the empty set, or no solution. There's no possible x that makes that true, so we don't have an answer. And one other thing I want to make note of before we move on, let me continue my squiggly over here. Oh no! Oh no, I lost my squiggle, and it was such a good one too. Alright, there we go. Let's say you had a problem that looks like this. 2 times, let's see, x plus 1 over 3 is greater than or equal to 0. Okay. Anytime you have, why did I do that? I put greater than, and I'm doing less than right now. I got ahead of myself there a little bit. Less than or equal to 0. Greater than is a different story. If it's less than or equal to 0, let's think about what this means. We've already established that an absolute value cannot be negative. So it could never be less than 0. So really all this means, if you see this, is turn it into an equation. This means the absolute value of 2 times x plus 1 over 3 is equal to 0, because that's the only way that's going to satisfy that inequality. It can never be less than 0. So really, this is going back a section and asking you to solve an absolute value inequality, or I'm sorry, an absolute value equation. So whenever you see that, just know, oh, this is just an equation. I can set it equal to 0 and solve. And it's pretty straightforward to solve it from there. I'll leave that to you. All right, let's move on. That was when the absolute value is less than a number a. Now let's look at when it is greater than. I don't know why my squiggly lines keep disappearing, or maybe I never drew one there. I don't know. So again, we've got this qualification here. We've got a qualifier. A is a positive number. If a is positive, then the absolute value of x is greater than a means this. It means actually two things. You have to write out two separate inequalities here because it turns into an OR problem. Because think about what we're saying. Let me give you a visual here with a number line so you understand why this is. If I say, for instance, well, I'm still highlighting and I mean to be drawing. Get rid of that. If I say the absolute value, well, I for some reason cannot draw there apparently. Just a second, we'll fix this. The absolute value of x is greater than, let's say, 2. What are we really saying? We're saying that x is at least 2 units away from 0. Well, let's look at what that looks like on a number line. Here's 0. Here's positive 2. Here's negative 2. What we know is that all of these points from here to here, from negative 2 to 2, all of those points are within 2 units of 0. So those would not fit this inequality. Any point in here would not make this true. So the solutions to this inequality are outside of that range. So let me highlight them. From negative 2 this way, and from positive 2 this way. So we're saying any number that's bigger than 2 or any number that's smaller than negative 2 is going to have an absolute value greater than 2, because all of those numbers are at least 2 units away from 0. Because, you know, like if I pick, let's say I pick 5 out here. Well, 5 has an absolute value of 5, so that's bigger than 2. If I pick negative 3, and of course I managed to erase my highlighted port. Oh, this is good. This is getting better and better. Every time I try to use my pen, I erase something magically. Nobody knows why, but that's what's happening. So if I pick negative 3, if I were to come here and choose this point right here, well, that has an absolute value of 3, which is bigger than 2. So you can see any point that's in these green shaded areas is going to satisfy this inequality. Whereas when we had a less than symbol, we would have been wanting all of these points in here. This was when it was less than, the purple points there. The green ones on the outside are what we're looking for in this case. Alright, so that is why we have to have this compound statement here. X is less than negative a, in this case negative 2, or X is greater than positive 2. Right, so that's what we're looking at. So let's look at a basic example. Let's see, let me go back up and make sure I use the same one. Y minus 3. We used y minus 3 is less than 7 earlier, so let's look at the absolute value of y minus 3 is greater than 7, and you'll see how these fit together. So what we're saying this means is either y minus 3 is less than negative 7, or y minus 3 is greater than positive 7. I'm just following this format right here that I've circled. That's all I'm doing here. I'm taking that 7, I'm making it negative, and then I have to make the sign less than. And if I solve these two inequalities, that will give me my solution set. That will give me these two green areas that I've shaded in the picture right above this. So let's do that. Let's do just that. So again, I mean, it's pretty straightforward to solve. I'm just going to add 3 to both sides. And that's going to give me y, if I can get my stylus to cooperate, is less than negative 4. Or, if I add 3 over here, y is greater than 10. So if we look at this on the number line, here's negative 4, here's 10. If I were going to graph this, I would have a parenthesis here, right, because it can't equal negative 4. And I would be shading everything left of that. And I'd have a parenthesis at 10, and I'd be shading everything left of that. So let me fill that in here. Okay, so there's my solution sets. Everything that's outside of that window from negative 4 to 10 is a solution. So how would I write that in interval notation? Let's give ourselves a little more space here. This is the same as saying, well, this interval over here is negative infinity to negative 4. And then we have to have a union symbol, because we know when we have more than one interval, we combine them with a union. Wow, my attempt to trace that did not go well. Let me see if I can. Oh, really? Now the eraser doesn't work. When I want the eraser to work, it won't erase. Well, I'm just going to give up, because my union is apparently terrible currently. Union 10 to infinity. Okay, so what we're saying is x, or y in this case, could be anything in this range over here, or it could be anything in this range over here. Either way, it's a solution to the absolute value inequality. All right, all right. Let's look at another one. The absolute value of 2x plus 9 plus 5 is greater than 3. Put some squigglies here. Let me give some more space. All right. Now remember, from before, we have to get the absolute value isolated. So the first thing I'm going to do is subtract 5 to move that 5 out of there. So now I have the absolute value of 2x plus 9 is greater than 3 minus 5 is negative 2. Now think about what this is saying. Think about this statement right here. When we were doing the less than symbol, this meant we did not have a solution, right? Because you can never have an absolute value that's smaller than a negative number. Well, think about what it means now. If we want some absolute value, we want whatever this turns out to be in here. I'll highlight it a bunch. Whatever 2x plus 9 turns out to be, we're going to take the absolute value of that, and so that is automatically going to be a positive number. That's my attempt to make a plus sign. That's automatically going to be a positive number on this side. Well, so no matter what it is, any positive number is going to be greater than negative 2, right? Of course it is. So what does that mean for x? Well, no matter what x I plug in, no matter what I plug in here, I'm going to get a value that's greater than negative 2. So even without working this, without following the process at all, I can tell you that the answer is all real numbers. X is all real numbers. And how do we write that as an interval? We write negative infinity, comma, infinity with parentheses around it. all real numbers. So whenever you see an absolute value is greater than a negative number, that should tell you all real numbers. However, if it said this, remember, let's go back for a second, when we were dealing with less than, if it said the absolute value of 2x plus 9 is less than negative 2, that's not possible. That gives us the empty set. Sorry, that's supposed to be a 0, not an upside down Q. And now it's a guy with a little tuft of hair on his head. Sorry about that. Well, let's give him a face. Why the heck not? I mean, we've gone this far. Why does this guy have to have a line through his face? I don't know. But that's the empty set. Right? So if you can't have an absolute value less than a negative number, but you absolutely can and will always have an absolute value that's greater than a negative number. Okay, I think that's enough. I think you can probably work all of these problems that you need to, and I'll let you get started now.